Okay, so same again, we'll just carry on. State the number, well, read the question and pause it, but I'm just going to get cracking. So state the number bacteria present at the start. As we discussed before, it's going to be this number here. My graph is looking like this, where this number in here will be the 200 point. This is a growth function, there's no negative. So 200 is going to be your starting point. That's excellent. Calculate the number of time taken for it to double. Well, if I start at 200, then it's going to double to 400. So 400 is 200 e to the positive. There we go. So divide by 200, that's going to give me 2. And quite an interesting point here, when you get to this bit, 2 means doubling. Okay, so actually, if you're, I wouldn't suggest going straight to this point. It's a good way to check in. If you're doubling, this will be 2. If you're halving, this will be a half. Okay, once you've got e on its own. So I'll just have a wee watch out for that, yeah. Because this is taking out the actual numbers and just giving you what's happened to your function. This function has doubled. Okay. And how do I possibly get this away from the power? Well, we use our logs, so we can use the power law. So if I take logs of both sides, I'm taking the natural log of both sides. So that's e to the 0.107t. And by doing that, the log and the exponential cancel. So I'm left with natural log 2 is 0.107t. Rearrange that, so I'm dividing by 0.107. That's going to give me t. Try that in your calculator, it should come out as 6.48 hours. So nothing too tricky, I don't think. Like I said before, it's really just known to take the logs here, and then this cancels each other out, because remember, ln is your natural log, so ln base e. So that was ln, that was log e to the 0.107t. So yeah, that's what's happening with that one. Yeah, I suppose if you want to think about it, actually, just, why does it cancel? Well, say we did a nice one that we like. If that was log 10 100, that gives me 2, because what we're saying is 10 to the power of what gives me 100. Well, 10 to the power of 2 gives me 100. So let's try this one then. I'm saying e, like this, e to the power of what is going to give me e to the 0.107t. Well, it's that, isn't it? So this is going to come out as, log e to the e 0.107t. That comes out as 0.107t, because e to the power of that equals this. Yeah. So that's why it cancels out. You don't need to know that, but that's what we're doing. Okay. So great 5 marks. I mean, look how long that took me. I've been chatting, just silliness, just riffing, and that's only been 3 minutes into the video, and you just got yourself 5 marks. If all your marks are like that, you finish very quickly. So very good one to do. I'll try this one. So it's slightly different. Look, numbers look a wee bit harder here, don't they? So have a little read at the question, and then we can go through. Yeah. So I hope you read that. Quite a wordy question, isn't it? Very wordy. But we're just doing the same thing, aren't we? So we're looking for 50% of customers who wait less than 3 minutes, and P is that percentage of customers who wait less than T minutes. So T is going to be our 3, and P is going to be our 50. So substituting 50 is equal to 100, 1, take away E, and I'll just write 3k rather than k3, doesn't really matter. Okay, so I've just done right now successful substitution, probably a mark for that. And then I'm going to rearrange. So divide both sides by 100. So 50 divided by 100 would give me a half. Well done there. Get rid of my 1. So that's negative a half. Is negative e to the 3k. And I think I'll get rid of these negatives. So we'll multiply through by negative 1. So a half is going to be e to the 3k. I'm going to do what we did before. Take my natural log. So it's natural log of a half is equal to natural log e to the 3k. So by doing that, these cancel out and I'm left with ln, natural log a half, is equal to 3k. I want k on its own. So, well, using quite a lot of working, natural log half, divide it by 3 will give me k. So that should come out as negative 0.231. So this one, FYI, looks like it's going to be a diminishing function, doesn't it? So that's our first bit. Again, looks worse than it is, It's a simple rearrange, okay, so don't be confused with all the numbers and the letters, just a simple rearrange. And this is the key bit. We use our natural logs to get this down. The next bit, the percentage of customers who wait for 5 minutes or longer. So this, as you can see, there's 2 marks for this. So usually it was asking for the original amount. This is a slightly different question, but really it's just asking you to substitute in. So we're saying, okay, well, how many customers, P, are going to wait 5 minutes or longer? So 1, take away E, and this time I've got negative 0.231 multiplied by 5, because 5 minutes or longer. Okay, so I've just substituted in the K that I worked out, which was in there, and the 5 multiplied by 5. So this is going to work out as, I've got 68.5% if I round it. Okay, so that's saying the percentage who wait less than T minutes. And this is saying who wait longer. So I know that 68.5 waited less, so that means I'm going to have to say 31.5 are waiting longer. So there's a little extra step there. That's why you're getting the 2 marks. Not as simple as a straight substitution. So the wording for that was a wee bit tricky. You might have lost it on that last mark. But in essence, this is what you get with these questions. You get to demonstrate you know how to take logs of both sides, and that you can substitute and work your calculator and break through the maths and understand what you're doing. So just be careful and read the questions for these, okay? But if you made that tiny mistake, you would still pick up 5 solid marks. And again, how long did that take us? Not very long. So it's a great question to do. Let's have a go at this one. So how about we read again? Pause the video, have a wee read and see what you think. So yeah, the first one, 1 mark. It's just going to be a straight substitution, isn't it? So calculate how many points. There's your time. And there's your distance. And my equation, I've just got time in it, actually. And that's for the 200-metre event. So I don't even need to worry about that. I'll just say the number of points is 4.99087 multiplied by 42.5. Take away the time. So that's 24.55. 1.81. So that should come out as 929.04. Just a straight substitution with your time. A few numbers in there trying to mess you up. So we didn't need the 200 because this is the formula for the 200. Next one. So 4 marks. I should be thinking this is probably going to be the rearrange. Given that 850 points are awarded for the 600-metre jump, calculate the value of K. So yeah, we've got a D and a P. So I've got a distance and I've got points, and sure enough I've got points and a distance, and I'm going to find K. So my points then for that one, 850, that's going to be equal to 0. I try and write this neat, because I think the first time I did this I kind of missed out an 8 or something. Very easy to make a silly mistake like that with these. Don't forget you do get carry-on marks if you make a small mistake. It's just, you'll lose 1 mark, but you're not out the game. So there we go, power of K. So my D is 600. I'll just check the units for that as well. Yeah, in centimetres. That's how they can maybe try and get you. Is it in centimetres? You have to convert it. But no, that's all good. So what do? Well, we just rearrange it. So 850 divided by 0.188807. So that's going to be equal to, and I can just do the sum for this, can't I? I'll call that 390 to the power of K. Fantastic. And how do I get K down? Well, I'll take natural logs of both sides. So I'll take the natural log of this, 850, divided by 0.188807, and that'll be the natural log of 390 to the power of K. I can then bring K down. I can say, fantastic, I've got my natural log. This is getting quite big to write, but K ln of 390. So slightly different this time. It's not cancelling out. We're simply putting the log there so that I can then bring the K down. Yeah. So did I have to take the natural log? No. I could have unlogged to base anything. As long as there's a log in here, I could have brought it down. I'm just sticking with the natural log because that then works really well for the exponentials. So it saves us having to think, which log am I going to do? And then finally, I'll say log of 850